All right, your American Public Transportation Association operator protection and features for the rail transit vehicles, and then it will go into introduction overview operator protection features, structural strength of the front end structural strength of the side structure of the cab, gazing padding and avoiding sharp corners, telescopic traffic gear, back couplers, anti-climate device, pilot with the crash emergency management, survival space, the ergodynamic cab seat, cab emergency lighting, the cab design, rapid evacuation, secondary emergency exit for the cab converter, alarm, fire suppression, ventilation control, visibility of the cab from the exterior, operator field view of the surroundings, automated vehicle tracking, operators communications, cab securement, other transit system requirements, other related APTA standards, reference definition, abbreviation, acronym, summary, and documented history. We'll skip the introduction and then move to the operator protection feature for the rail transit vehicle with the overview. In most railway transit systems, the driver operates the vehicle autonomously for a reason of the safety of the operator with his or her own going ability to operate the vehicle. The critical the operator must be able to bring the vehicle to safely stop after an incident, move the vehicle as if the passenger immediate area with the threat of the use of the vehicle to support the emergency response activities, all the subject of the operator surviving the collision on attack of the vehicle control system remaining in function. On heavy rail vehicle, operator usually isolated with the passenger security compartment. However, the light rail vehicle, the operator can use the main body of the vehicle, but the operator needs to be able to interact with the passenger. Threats against that can be minimized. The vehicle design. In the event of the incident with the onboard transit system, the law enforcement emergency response agency need to be able to assess the situation quickly as easily as possible. Their ability to see what has been taken with the vehicle, but the currently happening will be able to respond with a manner that helps protect the transit passengers operating the vehicle with the first responder. Similarly, improve with the vehicle, the operator ability to see what is taking place around the vehicle to enable the operator to respond more quickly to impend threats of the developing situation. Operated rail transit vehicle needs for the vehicle to design afford him an error much of the protection possible with the three main reasons. Operator is vulnerable to the force of the front end of the side collision. The anticipated the operator must be safe with the passenger with a greater risk. Operator's potential target of the criminal terrorist attacks. U.S. and European railway industries have created the Crash Emergency Management System, or CEM, standard published for the American Society of Mechanical Engineers and European standard. The standard required the rail vehicle to absorb any of the injury of the energy and collision, reducing injury for the operator and the passenger. The Crash Emergency Management System becoming mandatory with equipment governed by the Federal Railroad Administration for the mandatory with the new European vehicle that includes street trains, commuter trains, regional trains, intercity trains. Certainly, with the collision for the perspective of the rail transit vehicles operate a less severe environment than commuter railway vehicles. For example, the rail transit vehicles operate at a lower speed. The rail transit vehicles sometimes operate unsignaled dark signaled territory. Rail transit vehicles often operate dedicated to right-of-way operating with equipment. The rail transit vehicles are lighter in weight. The rail transit vehicles, should they become involved with a collision and accident, face lighter weight obstacles that tend to hit lighter objects. Rail transit vehicles with a higher braking rate with a avoid collision. Collision to advanced technology signal train control system is often superior. While railway transit vehicles do not need the same energy absorption capability installed with a heavier commuter rail vehicle. The attention must be paid in installing crashworthiness features to protect the operator and passengers. Operator protection feature of the rail transit system. The process of the procuring the new vehicle with the retrofitting the existing vehicle with the overhauling existing vehicles should include the following vehicle features provided with the greater protection of the operator: structural strength of the front end of the structure, structural strength of the side structure, cab glazing even the interior of the cab compartment, the padding and avoiding the sharp corners, etc. Using a pushback coupler with energy absorption design, anti-climate to prevent override design, pilot other and front end of the structure, push away high vehicle with the other objects down with the deflect from the vehicle. The crash energy management collision absorption design principle for preserving the survival space for the operator and passenger of the after collision. Ergonomics of seat with the cab and emergency light with the cab design with the rapid evacuation, secondary emergency exit with the cab converting alarm, fire suppression, and with the cab ventilation control with the cab of visibility with the cab area with the exterior operator field review of his or her surroundings, automated vehicle traffic redundant of the means for the operator communication with the central control means your cab of the entry for the public of the manual overriding the cab borne public address system. The need for the incorporate any of the features related to the rail transit system should be evaluated in terms of the safety risks. For example, the vehicles under advanced train control systems and for the train separation might not require additional secure structural reinforcement, collision, energy absorption, and equipment, which is designed to protect the crew and the passenger for the forces of the would occur with the unable accessible risk of the vehicles collide due to the human or single point of the equipment failure with the grade separation of the van with a single system integrated grade crossing protection significantly reduce the risk of severe collision under certain circumstances with the investment of the right-of-way safeguards balance if it is needed to add vehicle structure equipment to avoid collision and survival. Crashworthiness aspects should always be assessed pursuant to safety certification entire vertical acquisition project. R2-1. The structural strength of the front of the end of the structure. Structural strength of the front end of the structure provide the primary protection from the operating event of the collision. A front end of the structure make it to the corner post for each of the corner collision posts at approximately 1/3 points laterally and monitoring with a crash emergency management system. The collision corner post should be joined with the car body with attachment strength with allowed with the full strength of the post with the coming into play with the joints pad with the collision of the corner post should be made with the material with allowed with the post larger to the flexion of the bending of the before with the failure with the ductile rather than brittle failure of the absorbent any of the energy alternating of the crash emergency management system. Blame with American Society Engineers RT1, RT2, Engineer EN 1522 7 with the absorb the energy provided with the collision wall can also be used. For light rail operation, the General Railroad System of the American Society of Mechanical Engineers Safety Standard of the structural requirement of the light rail vehicle, the European Standard Crashworthiness requirements, railway vehicle body for the guide and front end of the structural strength requirements of heavy rail vehicles, American Standard Mechanical Energy, Safety Standard structural requirement of heavy rail transit vehicles with the guidance for the front end of the structural strength requirements. Rail transit system should hold the car builder design of the front end of the structural specific performance of collision scenarios approved with the rail transit system validation design should be through the combination components of the structural test remodeling of the validated computer model. Your structural strength of the side structure of the train with the side structure to protect for the operator with the passenger van with the side impact with the support with the roof of the event and with the rollover the light rail operation with the General Railroad System of the American Society of Mechanical Engineering Safety Standard with the structure requirement of the light rail vehicles with the guidance for the side structural strength with the requirements of high rail vehicles of the American Society of Mechanical Engineers Safety Standard structural requirements of heavy rail transit vehicles for guidance on side structure of the train requirements. Rail transit system should hold with the car builder responsible for the design of the structure of the specific performance on the collision scenarios approved with the rail transit system. Validation of the design should be through with the combination of components of the structural test of modeling validated computer model. Cab glazing is provided with the operator with the field view with protecting the objective of the entering of the cab. Glazing requirements should be considered with the feature with the optical characteristics outlined with the ANSI with the Z261. Front windshield should comply with the FRA Type 1 level of certification ballistic large object with a small impact per Title 49 Part 223 with the alternate internal standard with approved with the Rail Transit System S. All cabs side glazing with comply with the FRA Type 2 with the certification ballistic large small object with impact with the alternate international standard approved with the Rail Transit System. Cab rear interior glazing minimum should be constructed in laminated safety glass for the meet for the requirement of the ANSI Z261 American National Standard safety glazing, materials glazing, motor vehicle equipment operating land, highways, and safety codes. 2-4 padding avoiding sharp corners surfaces for the operator likely to impact with the rapid deceleration caused by derailment with collision should be padded. Sharp corner with the protrusion of the cab should be covered. The injury for the poor could cause operator injury should be avoided. Telescope of the draft gear pushed back up with a couple of the draft gears should have an energy absorbing energy to reduce the structural damage of the vehicle to protect the operator of the passenger for the coupling and collision shock load. The performance of the new pushback with a coupler energy with absorbing the draft gear shall be verified through a combination of the prototype testing model related to computer modeling. Couplers should be self-gathering positive with the engagement hook with the receptacle with the design the restraint with the car body slewing with the overriding of the van of the collision between two similar equipped vehicles. 2.6 Equipment, anti-calamity device. The car body structure, the design of the resist the collision tendency for the structural colliding with the vehicle, override penetrating survivability space for the impact of the car body. The vehicle shall include the anti-calamity device designed to resist tendency to override with the penetrate into survival place with the indicated impact car bodies event with the collision with the coupler to collapse. The anti-colliding device shall be provision efficient, effective with the head of on the collision occur with the tangent track as well with the offset of the contact collision might occur on the system. 2.7 The pilot. The purpose of the pilot of the push object with the track before they get under the wheel with the rail transit vehicle event with the collision. Many other devices structure with a different name that may serve for the purpose of the pilot. The car builder shall present with the design of the pilot specifically design criteria with approved with the rail with the transit system. Light rail operation, the ASME, a safety standard with the structural requirement of the light rail vehicle with the guidance for the cabin and design using the pilots. 2.8 Crash emergency management. After completing hazards and analytic determination on an acceptable risk of collision due to the human error with a single point with the equipment of which vehicle with the protected with the crash emergency management system attenuates the collision energy of the preserve survivability space for the operator. Crash emergency management the design parameters should be for the size of operation of the operator as well as the passenger. Accessible standard that meets the ASME as standard safety structural requirement of the light rail vehicle, the European standard crash worthiness requirements of railway vehicle bodies. Crash energy management system design should be verified with a combination of components of structural testing model and validated computer model. 2.9 Survival space. After collision space for the interior cabin must be maintained with the ensure that the occupants survive with the structural collapse with non-intrude the minimum volume within the around the operator with further design parameters for the further guidance preserve the survival space for the operator refer to a European standard EN 1522 railway application craft worthiness equipment of rail vehicle bodies. 2.10 Ergonomics with the cab seat. For the ergonomically designed operator with the cab seat should be installed with the provide with the range for the adjustment of the comfort required for the minimum of the operator discomfort, the fatigue with the duration along its working period. Selection operator seating should be based on the document ergonomically study with the history of the app will insert with the experience with identical seating. Alright, 2.11 Cab emergency lighting with the cab should be designed with emergency lighting with the meets requirements of APTA standards. Standard emergency lighting system designed with the rail transit system design vehicles. 2.12 Cab design rapid evacuation. The cab should be designed free of obstruction and MP for the operator with the rapid evacuation of the cabin event with the fire impeding collision or other emergency situations. See section 213 221 for additional requirements. 2.13 Secondary emergency exit for the cab. The cab should have the designated for the secondary means this cab will allow the operator self to evacuate the cab for the primary exit that becomes inoperable or blocked. 2.14 Cab covert alarm. The cab operator cab should be equipped with a covert alarm that allows the operator to inform central control of the duress situation, alerting any of the perpetrator if the alarm has been set. The system should be designed to operate the van with vehicle power failure. 2.15 Fire suppression. Automatic fire suppression overheating alarm shall be installed at the location of each of the early to detect with the fire impede with the fire suppression evacuation may be delayed. The care should be taken with the system not to pose the risk operative with the passenger, for example, to avoid situation with the suppression to placing oxygen for the National Fire Protection Association 130 fixed guideway transit passenger rail systems for detecting suppression protection requirement. 2.16 Ventilation control. Operators should have the manual ventilation control allow the operator to select how the ventilation system. 2.7 The visibility of the cab from the exterior of the operator cab should be designed to enable the police, fire department, and other emergency responders to see inside of the cab to assess the operator's condition. 2.18 Operator's field view of the surrounding operator cab should be designed to provide the operator maximum field view of his or her surrounding uninhibited view allow for the operator maximum response time to avoid accidents and enable the operator to detect a potential security threats. 2.19 Automated vehicle tracking. The rail training system rail control room shall be able to determine the vehicle position system consistent railway requirements of rail transit system plan. Alright, 2.20 Operator communication. Operator should provide with a redundant at least two independent means to communicate with the central control of the means of the communication designed with continue operating the event of the vehicle power failure. The vehicle should be designed the means the operator to communicate with the passenger to communicate with the operator. The system should also be designed to operate in the event of the power failure. 2.21 Cab security. The security reason for the operator with the cab door that should be capable of the lock for the prevent authorized person interfering with the operator performing their duties Locking operator compartment of the U.S. Transportation Security Administration guidance. The passenger accessible side of the operator cab door should not be equipped with the door handle. Should be designed with a manner that prevents forced entry into the compartment. Primary exit of the operator compartment of the passenger compartment should be equipped with a quick exit device for the operator of the open door cab, almost impede the event of the impending of the collision of the fire. Other rail transit system requirement. The rail transit system consider the other protection devices and emergency systems similar to those outlined in the APTA RT VIMS 026-2012. The rail transit vehicle passenger emergency system. This may include convert microphone into the cab connected to the recorder central control. Seat belts, operator seat, converted front bumper to put effective passenger and road vehicle to prevent a collision. Related APTA standards, reference definitions, abbreviations, some of the changes to document history. And that was your operator's protection features for transit vehicles.